Now let's get into the second derivatives. So, what is a second derivative to begin with? The second derivative is essentially the derivative of the derivative. Alright? So as an example, if we have y equals x squared, our first derivative, alright, we'll just find the derivative here, so we'd have 2x. For our second derivative, we would find the derivative again. So we'd find the derivative of this function here, which would give us 2. Alright? So in that way, it tells us information about the original curve, but since it is the derivative of this curve, it also tells us the gradient of this function. So it's a very kind of complex and interesting relationship, alright? Let's have a look at these diagrams. So, up the top we have our y function. Here we have our derivative function, and here we have our second derivative function. So, before we get into these dotted lines or anything, let's just make some observations. Firstly, as we're going down, our derivative is getting kind of less and less curvy, right? Our first derivative has a few curves. Our second derivative is just a simple parabola, and our second derivative is just a straight line. And as you might be able to tell, that's because as you're deriving down, you're kind of making things simpler. So as an example, our curve up here might have been something in the order of a cubic. Alright, it would be more complex than that, but it would be something like that. Our first derivative would be 3x squared, and our second derivative would be 6x. So as you can see, it's starting at a cubic, which is more curvy, then it's going down to a parabola, which is what we see here, alright, and then it's finally going down to a linear, which is what we see here. So, without even knowing, or without necessarily labeling the functions, if we hadn't labeled the functions, if you were in a multiple choice, for example, you would be able to tell which is the derivatives, alright, because we're getting less and less curvy as we go down. Now, let's have a look at the actual value of the derivatives. So, looking at this first y function here, let's identify when the curve has a positive and negative gradient. So what I'd like you guys to do is pause the recording and go through and maybe draw this curve out in your notebook and identify when the y curve has a positive gradient and when it has a negative gradient. Alright? So, it has a positive gradient up here, right, and a positive gradient here. Then it has a negative gradient down here. Alright. So, let's go now and look at our derivative, our first derivative, and see what patterns we notice. When we have our red curve, so we'll just look at this part, when we have a positive gradient here, our first derivative is above the x-axis. Alright? So when the gradient of the function is positive, our gradient function will be above the x-axis. And this makes a lot of sense, right? Because when it's above the x-axis, it means that the value, or the y value, is positive. And remember, the y value here is just our gradient. So this makes a lot of sense. You can see a similar thing over here. We have a positive gradient here. Our curve over here is above the x-axis. Looking over here, where our curve has a negative gradient, then our first derivative is below the x-axis. All right, so this is how you can identify which gradient correlates to which curve. All right. Now let's move on and let's identify when our gradient curve has a positive and negative gradient. So I'll give you guys a minute to pause the recording. All right. So our first derivative curve has a negative gradient down here and a positive gradient up here. Now I want you guys to have a look at the second derivative and see what that tells us. All right? Have a guess. When this curve has a negative gradient, our second derivative has a negative value. It's below the x-axis. When this curve has a positive gradient, our second derivative curve is above the x-axis. Alright? So, let's now get into what the second derivative tells us. So let's have a look at the relationship between y and y double dash. Going back to when our curve has a positive and negative gradient, right? There's one other really important metric that we can look at, and that is the concavity of the curve. All right? So the concavity of the curve is a little bit different to the gradient. The concavity is essentially which way the curve is facing. So I'll pick different colors for this. Here, our curve is concave down, right? And here, our curve is concave up. So, let's have a think about this. A really good way to kind of visualize this intuitively is to think about your function, all right? And think about it raining down on your function. And you think which parts of the function will catch rain and which parts will deflect rain. All right? So the purple part will deflect the rain, right? Whereas the green part will catch the rain. Okay? So the other important thing you need to understand is when those two concavities change. All right? So the concavities change usually about within the middle of where there is a concave down section and a concave up section. Not always, but usually. All right? The other thing you can tell is most of the time it is also the steepest part of the curve. All right? So as you can tell, or like locally of the curve, it's flat here, right? Going down, 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 down. It's getting really steep here, and then it's kind of flattening out again. So in this middle, that is where it is the steepest. All right? So I'll draw you guys a few examples of some concave down and concave up curves. So this is getting into the concavity. So concave down might look like that, or that, or that, right? Or even that. Okay? concave up might look like this, 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 or even very gently like that. Alright? So it's all just about thinking, would this part of the curve catch rain or would it deflect rain? Alright? So this is concave down and this is concave up. Now let's think about when those two concavities change, it will look something like what we have up here, right? We'll have a concave down part, and it will transition into a concave up part. So our point of inflection is in there. So what you might notice is that, and we'll get into more about points of inflection later on, so it will make more sense as we continue on. Look, we're looking at points of inflection right in the next topic. This point of inflection here, where the concavity changes, as you might be able to tell, we actually have a stationary point on the first derivative here and an x-intercept of the second derivative here. Alright? And what you might also be able to tell is that where our curve is concave down, our second derivative is below the x-axis, and where our curve is concave up, our second derivative is above the x-axis. And then when it switches over, we have an x-intercept. So hopefully this will give you a little bit of a hint as to what we're going to look at in the next topic.